Okay, welcome back. Welcome back to our channel. Today we are diving into the system design of URL shortener, something like Tiny URL. Whether you are preparing for your interviews or designing scalable systems, this breakdown will help you understand how to handle millions of requests efficiently. So, let's get started. First, in your system design interviews, when you have been asked about designing something, first we need to understand what that thing is. So, what is a URL shortener? URL shorteners are incredibly popular, especially in the age of social media, where concise links matter. Here is how they work. Basically, like at high level, a URL shortener takes a long unwidely URL and creates a shorter one. It's pretty simple thing. Actually, its name comes in what it's doing. So it's like it creates like a unique alias that redirects users to the original URL. But how do we ensure that this process is fast, reliable, and scalable? Let's break down this one and this one. What we're going to ask in our system design video. And in your system design interview, when you have been asked about something, first you need to know what is it, and after that we need to basically go to the next step, which is to gather the requirements. And gathering the requirements will have three things: functional requirements, non-functional requirements, and capacity estimations. And I would say this is the most important step in any system design interview, and you can basically get the functional requirements and non-functional requirements and capacity estimation by basically asking a lot of questions to your interviewer. So in order to gather the functional requirements, we get that we need to generate a unique or a short URL for any given long URL. It's a pretty simple thing. We need to redirect users to the original URL when the short URL is accessed. Number three, it's optionally like allow users to customize their short URLs, and we'll talk about that in the deep dive. Also, we need to support link expiration where URLs become inaccessible after a certain period. And lastly, optionally, we need to provide analytics on a link usage, like the number of clicks and geographic distribution. Okay. We need also okay, I guess this is enough. Let's not add anything else because we don't want to make the video unnecessarily long. I would say in your system design interview, when you finish all of that, please, 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 for the love of God, do not assume anything. When you put all of that, ask your interviewer, is this okay? Is this right? Should we continue? Or should we go to the non-functional requirements? I guess if you put five functional requirements, I guess it will be good. It will not be like he will not ask you to put more. Hopefully, if he asks you to put more, okay, good luck with that. I don't know what to say. However, it's time to go to the next step, which is the non-functional requirements. The non-functional requirements, I guess, for any URL shortener, we need to have high availability because the service must be up for have like 3 nines of the time. We need to have low latency, like shortening and redirection should occur in milliseconds because this is how actually they work. They are pretty fast. Also, we need to have a scalable system because the system must handle millions of requests daily. Also, we need to make our system durable. Short nodes URLs must remain functional for years, so we need to make it durable. Also, we need to make it secure because the service must prevent malicious usage, such as phishing, for example. Okay. Also, in this section, when you finish it, ask your interviewer, do I need to add any more bullet points? Are we good there? Something like that, because they might have something in their mind. Okay, let's talk about the capacity estimation. The capacity estimation, I guess for this one, we'll have a lot of things. First, we have the traffic characteristics. Like, I guess we have 1 million URL shortener requests per day, 100 million redirection requests daily with like 100 to 1 ratio from read to write. So we have 100 to 1. So our system is read heavy. The peak traffic is expected to be 10 times the average load. So basically, we exploding. We have like 1,000 million, like billion. In terms of the throughput requirements, we need to write the writes per second. We have like 12 during average load, peaking at 120 reads per second. It's like 12, 1200 during average loads, like being at 12,000. I would say let's continue to the storage requirements. Let's see that the required about 127. So for the short URL, like long URL or metadata, so we have like annual storage for 365 million URLs, about like let's assume 50 gigabytes. So we doesn't have that much of storage. Storage is pretty simple, it's pretty low. If we want to talk about the bandwidth, daily bandwidth for redirection will be about like 50 gigabyte, and peak bandwidth will be like 6 megabyte per second. In the caching requirements, we cache 20% of the most accessed URLs to reduce database load, because we said in the non-functional requirements we need to make it low latency, so we will use a cache. And there are some keywords when you hear, you know what we're using. For example, we need a low latency. We mean basically we are going to use cache. High availability, most likely we are going to use a load balancer. Um, um, Also, like durability, that means we need to make our system quite simple, so we don't have that much of complexity. Okay. When since we finished all of that, we can start in the next step. The next step, it's always be a high level design. In the high level design, we just put the bigger component, and after that, we go to break them one by one in the after step, which is the deep dive step. So we have our user, which or our client. Let's say the client, which can be let's assume it will be like mobile, mobile or desktop. Okay. It will send the requests to a load balancer because we need our application to be available. The load balancer will distribute incoming requests across multiple application servers to ensure even load distribution and high applications and high availability. If one server fails, the load balancer redirects traffic to healthy servers. Okay, so we can say that we have our application servers. We have maybe two main services we're talking about. We have our let's 1 minute. Let make the application service like that, and let's make it white. And I want to make it with a dot thing. How can I do that? No, no. Well, I guess there is something. Um, okay, it's not possible. I guess. I guess it's possible because I have done it multiple times. Um, yeah, yeah. Okay. So this is our web application servers because we need our application to be as available as possible. So we will use more than one server. And oh no, 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 no. And in the application server, we will have two. What's going on? Copy this and yeah. In our application servers, we will have two main services. We will have redirection service, and we will have yep, we will have URL generation service, and we said this will be our web our application servers. This okay. So we have two main services. Okay, so let's talk first the application servers. These servers host the core application logic, including the API layer. They handle user requests for creating short URLs, redirection, and analytics. and they communicate with other components like the URL generation services, also redirection services, and databases. So we have two main services. Maybe our applications, our service, we have two main services. One will be the redirection service, and the URL generation. Let's start with the URL generation because it starts, everything starts here. So I guess we need to have like a database. The URL generation, responsible for creating a unique short URLs. It uses hashing algorithms or like base 62 encoding to ensure compact and unique identifiers. It can also validate and create custom short URLs as provided by users. Maybe outputs are sent to the database. In the database, I guess we can use. Okay, if we thinking about database, let's assume that it will be connected with like a DB. And when you are working with DB in your any system design interview, the first question that comes is whether are you going to use a SQL or NoSQL database. So to choose the right database for our needs, let's consider some factors that can affect our choice. Given these points, first we need to store billions of records. Most database operations are simply simple key value lookups. Read queries are much higher than write queries. We do not need joins between tables. Database also needs to be highly scalable and available. So given all of these points, I guess a NoSQL database like the DynamoDB or Cassandra or any, yeah, DynamoDB, I guess, is a better option due to their ability to efficiently handle billions of simple key value lookups and provide high scalability and availability. Um, and the next we said that we need to make our application quite fast. Let's put the database here because I guess also the redirection service needs to work with database. Let's make it like that. Because it will get the URLs from the DB. We said that we need to make our application quite fast, so we will use cache. Let's make it like that. Also, I guess in here we said that we need to provide analytics, so we'll use analytics service. Let's just make this like down here, and we need analytics on redirections and how many applications have been and how many URLs. So we have like analytics service. Okay. Analytics. Okay, so let's go back to the redirection service thing. In the redirection service, it handles requests to resolve short URLs into their original long URLs. It checks the cache first for faster response times. If not found, it queries the database and updates the cache with the result. We can use, I guess, read through cache algorithm strategy. Sorry, read through cache strategy because our system is read heavy. We have second, the database. Database, it stores mapping between short URLs and long URLs, along with metadata like creation time, expiration time, and click counts. A NoSQL database like DynamoDB or Cassandra ensures scalability and high availability for read workloads. So we will use that, and we talked about that actually. The cache, in order to talk about the cache, I guess an in-memory store like Redis or Memcache is used to cache frequently accessed mapping, reducing database load and improving latency. Configured with like a time to live policies to keep cache memory use efficient. Also, we have analytics service. It's an optional thing. We need to track user interaction, such as the number of clicks on short URL, geographic data, and usage pattern. We need to process data asynchronously to avoid slowing down core systems operations. Also, we can have like some sort of background jobs because periodically checks for expired URLs and remove them from the database. We need to make pre-warm the cache with frequently accessed URLs to make sure that we don't have any cache miss in the first cache in the first request of any URL. We can be also this can be implemented using task queues or serverless solutions like AWS Lambda. Um, this is a modular architecture, ensure scalability, fault tolerance, and optimal performance for your Shortener system. So naturally, we need to make a deeper dive into most critical of components in this system. First, let's just talk about the URL generation service. Um, I would say there are two common approaches for generating these short URLs. There are hashing and encoding, like a hash function, like MD5 or SH8256 creates a fixed length of hash from the long URL. The hash is encoded using base 62 to make it compact and URL friendly. I guess yeah, I guess that's the what we can talk about. Also, we can have like a unique ID generation because each new URL is assigned sequentially auto incrementing ID. Like this ID coding, this ID is coded into base 62 string to create the URL shortener. We might have custom alias because we have this in our functional requirements. It was optional. We users can provide custom short URLs with which must be validated for uniqueness and allowed characters. Like also we have link expiration. We talked about this one. The system can assign expiration data dates to links based on user input or default settings. Expired links are removed by background jobs or marked as inactive. We can talk about the redirection service right now. The redirection service maps short URLs to their original long URLs and redirects users. And we need to understand how this works. First, we have a lookup process. Like the service first need to check the cache for the mapping. If not found, it queries it queries the database. Um, in this one, we can use a read-through cache. So basically, the cache will be in line with the database, so the redirection service will not be connected to the database at all. But we can talk about this in other video, or we can think about it. Let's talk about the analytics service. The analytics service, if analytics are required, we can add an event-driven service to log user interaction, like something like number of clicks per URL, geographic data, and browser type, referring paging as well. We need to address some non-functional requirements to make sure that we are doing everything right. In terms of the high availability, we deployed servers across multiple regions with automatic failover. In terms of the low latency, we optimize with caching and indexed database queries. In terms of the scalability, we use a stateless API servers and database sharding. In terms of durability, we enable replication and periodic backups. In terms of security, we validate inputs, enforcing HTTPS, and monitor for malicious activity. So I guess this is the system. We can talk about, we can make like how it works. You know what? I should make a workflow example, but I'm not doing that. I highly recommend you to just create your workflow example and put it in the comment section. And the one that has the right the I will you know what, I'm thinking about creating another video to talk about what is the right workflow, and I will tell you something even better. If this is my system, okay, I need you to review the system that I created and tell me about some improvements that I should add to the system. And I will read all the improvements, and I might create another video to talk about all of these improvements. And I will just I will just show the link, and I'll just show the comment, and I give you a big shout out. And yeah, let's see how we will do like that. Let's start it like that. I'm pretty excited. So yeah, see you in next videos.